the rules for adding and subtracting fractions are simple. You must first get common denominators. Okay, and the reason why I'm saying why we're going to do this. Let's take a look at a fraction that we know how to do. Let's say 3/4 minus 1/4 is equal to what? Okay. Now, by drawing the circles, we're going to be able to solve this. What's going to be left here, everybody?
1/4.
1/4, right? I'm going to take away this part of the shaded circle, or that half of the shaded circle. And so I'm going to be left with that much, right? Because I took away that, that's all that's left. So I'm going to be left with 1/4. However, here the math works that 4 minus 2 is equal to 4. And 3 minus 1 is equal to 1, right? Wait, no. That math doesn't work, right? 4 minus 2 is 4. 3 minus 1 is 2. I just have 2 halves here, but I have 1 and 2. It doesn't work that way. And there's going to be a trick to this. And the trick is that I cannot subtract numbers or add numbers that have unlike denominators. What are the denominators? The bottom numbers, right. So these numbers are different. And so what we're going to do, this is my way of doing it, is anytime I have two fractions, I'm going to write them one on top of the other. And then from there, I'm going to put a times, a bar, an equals, a bar. Times, bar, equals, bar. To make this into, so I can start multiplying these to make my common denominators. Okay? And how I'm going to get my common denominators? This is one of the hardest parts of the fraction. Okay? Because I need these two numbers to make the same number. Okay? So I'm going to start with the biggest one. Now this is one way of doing it. In a little bit I'll show you guys a second way if you do not see this first way. This first way though is the most common way that is taught. And so I'm going to do it this way. Now I set it up vertically. Sometimes they will set it up horizontally and they will change them horizontally. I don't like to do that just because of the amount of space it's going to take. I end up moving more across the paper instead of down the paper. And I normally have more space going down than I have across. Okay? So I'm going to take the largest one, 4. And I'm going to either look at my times table or in my head I'm going to make a times table of 4. So I'm going to say 4 times 1 is 4. Does 2 make 4? Yes, right? I can say 2 times something makes 4, right? So then both of these numbers can make a fraction with a denominator of 4. So it's going to be 2 times 2 is equal to 4. 4 times 1 is equal to 4. And like we learned with our reducing and raising fractions, if I want to keep this number the same, which I do, I have to multiply it by a fraction of 1. So if 2 is on the bottom, 2 has got to go on top. If 1 is on the bottom, 1 has got to go on top. So 3 times 1 makes 3. 1 times 2 makes 2. And now, because I'm subtracting, I can subtract these fractions. So 3 take away 2 is 1. And we keep the same denominator. Huh? Can we reduce this? By what? By 2? I can divide 4 by 2. But I can divide 1 by 2 and still have a whole number. So no, this fraction is in its lowest term. Okay? Now one more.
Is this the easy way?
This is the hard way. Okay. I'm going to do one more in this hard way. Now I say it's the hard way because it makes us do the thinking right here. This part is thinking. Now the easy way I call the duct tape way. And I'll explain why we're going to duct tape. But right now let me do another add and subtract. We're going to do 1/2 plus 2/3. Okay? So I'm going to set it up. 1/2, 2/3. Times bar equals bar. Times bar equals bar. Okay? So I'm going to go through my times table of 3. 3 times 1 makes 3. Does 2 make 3? Can I make 2 evenly? No. Right? 2 does not equal a 3. 3 times 2 is 6. Now, does 2 make 6? Yes. 2 times 3. So 3 times 2 makes 6. 2 times 3 makes 6. Sometimes we have to change them both. Sometimes we're lucky, we only have to change one. So when I do the bottom, top. Bottom, top. That's 3, that's 4. Okay? Now I'm going to add those. 3, 6 plus 4, 6 and 7, 6. Are we done? No. This is an improper fraction. We're going to have to divide it. 7 divided by 6, 1 time is 6, and the 1, 1 whole, 1 part, and the denominator stays the same. 1 and 1/6.
So this time you have an improper fraction, then you could change it to the next number.
Improper is when the top number is bigger than the bottom number. The one, like the top page, the top half of that page is this. Okay? Questions? Okay. Now one more thing. Crystal, you doing okay? Okay. Now there's another method of doing this. This is going to be called the duct tape method. Ready to get it? Okay. So let's take 1/4 plus 1/6. Okay. The duct tape method is useful if you do not want to do that multiplying, or if the numbers are too big for your multiplication chart. Okay. I'm still going to set up 1/1, 1/4, 1/6, end up multiplying. Times bar equals bar. Okay. But this time, instead of bothering to think about this, I'm going to take this number, move it up here. I'm going to take this number, move it down here. You're going to multiply the denominators together. Yeah. That's going to get 24 and 24. That will always get you the same number. 4 times 6, 6 times 4, same thing. Every time. You don't need to stop and think. If you do the bottom, you do the top. Bottom, top. 1 times 6, 6. 1 times 4, 4. And then since we're adding, we add them up. 10, 24. Okay? Are we done? We need to check to see if we can reduce these. Like I said, 10/24 is similar to 8/16 a tank of gas, right? You don't want to do that to people. People hate fractions as is. So they want to see these fractions in the simplest form we can. This is the drawback of the duct tape method. Duct tape does something very quick, but when it comes time to clean that up, it's more work in the long run. Okay, than if you did it the right way the first time. Okay? So I have to divide these numbers down to their smallest parts. So we can say what goes into 10 and what goes into 24. Now, 5 won't, 6 won't, 4 won't, and 2 will. Now, if you don't want to spend time thinking about that, There's another little shortcut you can do. And it's going to always divide by the prime. Okay? The prime numbers are basically numbers that make up other numbers. They are numbers that are only divisible by themselves and 1. So the prime numbers are going to be 2, 3, 5, 7, not always odd numbers. Not 9. Thank you for catching that. 11, I was going odd. 11, 13, 17. Those are going to be the most common ones you're going to run into. Also 23, 19, you keep going a lot more. But normally, you just need to about 13. Huh? Why not 9? Because 3 times 3 makes 9. So 9 is made up of, yeah, it's a number that cannot be made from anything else. By multiplication. 2 can be made by 1 with addition, but not by multiplication, right? And 1 can make all of these times itself. 2 times 1, 3 times 1, 5 times 1, 7 times 1. But nothing else makes them, right? 9 can be made by 9 times 1 and 3 times 3. 15 can be made by 3 times 5 and 15 times 1. So they have other parts to them. These numbers don't have other parts. So we can check these. If they're even numbers, these are both even numbers, you can always divide by 2. If they end in a 5 and 0, or 0, you can always divide by 5. But I'm going to divide by 2, divide by 2. That gets me 5 over 12. Now I check 5 can only be divided by 5, right? So I can say, okay, I can divide that one by 5, but can I divide 12 by 5? No. So that's as low as it goes, 5/12. So that's the answer right there. And that's what we're going to do for this. All right?